So students, we have successfully completed exercise 6.2. Now let's move to exercise 6.3. Now in here, this question number first is that in the given figure, sides QP and RQ of triangle PQR are produced to points S and T respectively. So you will see here that this side QP is produced to point S and this RQ is produced to point T. So both, you can see here, both sides are produced to S and T. Then you can see that this triangle PQR now will have two external angles. One is 110 and the other one is 135, as you can see here, right? Now there are two external angles, and further what we have to do is we have to find out angle PRQ. So PRQ, this is the angle that we have to find out. Now one thing you will notice here is that both the external angles are given to us as 135 degree and 110 degrees. So let me first write the given thing here. So what is given to us? You can see angle SPR, that is 135 degrees, and angle PQT, you can see here PQT, that is given to us as 110 degrees. So we have got both the angles. Now one thing for sure, if you see this is a straight line, so they will form a 180 degree angle, right? So if I just simply subtract 110 from 180, I'm going to get this angle. And similar kind of thing is existing here. That means this is also a straight line. That means this is forming a linear pair. That means there is also 180 degrees. So it is also 180 degree. So if I just simply subtract 135 from 180, I'm going to get this angle, right? Now both angles can be extracted from here. Then you know in a triangle, sum of all the angles, all the three angles here, if you will see here, is 180 degree. So simply adding them and subtracting out them from 180 degree will get me this angle, right? So this is the whole scenario by which we will going to find out this angle, right? Now step by step I will move down here. First I'm taking this angle SPR, as we know here, is 135 degree, and we will find out first this angle. So how we will find out? We know that angle QPR plus SPR is equal to 180 degree because they are forming a linear pair, right? So this implies, let me first solve that, angle SPR plus angle QPR. If you can see here, QPR and SPR, both are going to form 180 degree because they are linear pair, right? So let me substitute the value of angle SPR here. So that is 135 plus angle QPR equal to 180 degrees, right? Now transfer this 135 over to right hand side. So this will give me angle QPR equal to 180 minus 135 degrees, right? So if I just simply subtract this, so 180 minus 135 will, 10 minus 5 is 5, so 7 minus 3 is 4. So 45 degrees is angle QPR we have got, right? Now next step is we have to find out angle PQR because it is forming a linear pair with angle PQT, which we know is 110, right? So let me just drop this question here because we know what we have to find out, and that is angle PRQ, right? So let me just write that to find here. So if I just have to write, you can also add a line here to find, that is angle, you can say PRQ. So this is the angle that we have to find here, right? Now let's move further to the next thing to find out this angle, right? That is named as PQR. So we know that angle PQT plus angle PQR is equal to 180 degree because they are a linear pair, right? So you can see here both the angles are adjacent to each other. That means they are forming a linear pair like 110 and this angle. So PQT plus PQR is equal to 180, right? So now what I'm going to do is simply substitute angle PQT right here, that is 110 degrees, plus angle PQR equal to 180 degree. Now you all know what we have to do, transfer this over to right hand side. This will give me angle PQR as 180 minus 110, and that is simply 70 degrees. So now we have got both the angles, 45, so this is 45 and this is 70 degrees. Now you all know in triangle PQR, sum of all the three angles is going to be 180 degrees. That we all know. So by simply adding them and subtracting them from 180 degree will get me this angle, right? So let me just rub this here. So we only need two angles, right? These one. So there is no need of other things. So in triangle PQR we have, so I'm going to simply add all the three angles. So this angle is QPR, this Q angle is PQR, and then PRQ. So let me just write that. So angle QPR plus PQR plus angle PRQ will be equal to 180 degree, because we know sum of all angles of a triangle is 180 degree. You can also write it in the bracket here, right? So let me just see that what is angle P here. So that is 45. So let me just place that. And the Q angle, that is 70 degrees, and R, that is we have to find out, right? So angle PRQ is equal to 180 degrees. Now simply add them. So let me just now rub this. So that will total me to 115 degrees, right? So PRQ equal to 180. Now simply transfer this over to that side. So this will give me, you can see here, angle PRQ equal to 180 minus 115. So this will give me angle PRQ as, let me just subtract this. So 180 minus 115, right? So this will become 10. So 10 minus 5 is 5. 7 minus 1 is 6. So 65 degrees, right? So this was the angle what we have to find out in this question, that is 65 degrees, right? So this is all about this question. So do practice it at home, right? That's all. So students, without wasting time, let's move to the next question here, right? Now question number 2 is, in the given figure here, the angle X you can see here is 62, right? Now further, if YO and ZO are the bisectors, you can see the bisectors of angle XYZ and XZY. So you can see here, so this angle Y is bisected by a line YO. So you all know what bisected means. That means divided into two equal parts. That means this way is actually dividing this 54 degree angle into two equal parts, right? Similarly, here this XZY, or you can say Z angle, is also divided by this ray ZO into two equal parts, right? So these are the bisectors of both the angles. That means they are dividing the angle into two equal parts. Here we know angle X and angle Y, you can see here, but we don't know angle Z, right? So first thing is we don't know angle Z. Now second thing is we have to find out angle OZY and YOZ. So let me just tell you where it is. So OZY, that means this angle. That means if we be able to find the whole angle Z, then simply dividing it by 2, that means making it half, will get me this angle OZY. Similarly, we have to find out this angle YOZ. You can see here. So YOZ is this. So let me first tell you the method by which we are going to find out both these angles. So if you observe, both the angles are in a common triangle OYZ. You can get in here, there's also a triangle forming in between the larger triangle. So this triangle OYZ here got three angles. This YOZ, then OYZ, this angle, and OZY. So if we be able to find these two angles, OYZ and YOZ, so OYZ and YZO, right? So if we be able to find out these two angles, then adding them and subtracting them from 180 degree will get me this angle, right? So this will be the trick. So first step is we have to find angle XZY, and for that we know this larger triangle will have sum of all the angles as 180 degree. So let me write that solution. So in triangle XYZ, the larger triangle, we got two angles here, angle X and angle Y. So let me first name them YXZ. So angle YXZ plus angle XYZ, it means this one, and then XZY. So XZY equals to 180 degree. You can also write in bracket the sum of all the angles of a triangle is 180 degree. You can mention here, right? Now let me first see what is angle X. That is 62 degrees, right? Now what is angle Y? You can see a 54 degrees. So let me write that. Now what is angle Z? That is what we have to first find. So angle XZY equal to 180 degrees. Now let me add them. So 2 plus 4 is 6. 5 plus 6 will be 11. So that will total to 116 plus angle XZY equal to 180 degree. Now transfer this over to the right hand side. This will give me angle XZY as 180 minus 116. So what is 180 minus 116? Let me show you here. So 180 minus 116. Now 10 minus 6 is 4. 7 minus 1 is 6. So that is giving me 64 degrees, right? So this whole angle is actually of 64 degrees. Now we know that this ray is actually dividing the angle into two equal parts. That means if we simply divide the 64 by 2, then we are going to get both these angles, right? So let me first rub some space so that I can understand. So I'm just leaving what we have to find here, that is OZY and YOZ. I've also mentioned it right here. So let me just rub the question here. So let me also rub this so that more space can be formed, right? Now let me show you that this angle OZY, that is first what we have to find out now. So OZY is simply half of this angle XZY. You can see it's half, right? So we know the whole angle. Simply dividing it by 2 will give me this angle, because this ray is actually dividing this whole angle into two equal parts. So dividing it by 2 will give me this angle OZY. So half of angle XZY, and we know angle XZY is right here, that is 64 degrees, right? So let me just place that. So at the place of XZY, I'm just simply placing 64. Now we can cancel it out. So 2 3 is 6, 2 2 is 4. So this will give me angle OZY as 32 degrees, right? So this angle is now 32 degrees. Now remaining is angle OYZ. So if we be able to calculate angle OYZ, so this angle, so by simply adding all the angles of this triangle OYZ and then adding these two and subtracting them from 180 degree will get me this angle, right? So this was our method, right? So now next step is, let me just put a line here and also rub this. So next step is, we know this complete angle XYZ, and we also know that this ray is actually dividing this whole angle into two equal parts. So simply dividing 54 by 2, we're going to get this angle, right? So we know that angle OYZ is simply half of, this angle is completely half of this complete angle, right? So XYZ. So angle XYZ. And we know angle XYZ is 54 degrees. It is given to us in the question, right? So simply solving this. So 2 2 is 4, 1 remaining 14. So 2 7 is 14. So this will give me angle OYZ. Let me just write it clear. So angle OYZ as 27 degrees. So this angle is of now 27. Now we know this is 32, this is 27. Adding them and subtracting it from 180 will give me this angle, because in a triangle, sum of all the three angles is going to be 180 degrees, right? So we don't need the rest of the thing. So let me just rub that. Now, thing is, in triangle OYZ, right? This triangle OYZ. So we know that angle YOZ plus angle OYZ and OZY will be total to 180 degree. You can also write again that sum of all the angles of a triangle is 180 degree. So that's the reason. So what is angle O? That is what we have to find out, right? So leave it as it is. Now what is angle Y? You can see it, 27 degrees, right? So what is angle Z? That is 32 degrees, equal to 180 degree. Now simply add them. So YOZ plus 27 plus 32. 7 plus 2 is 9. 3 plus 2 is 5. So 59 degree is the total. Now transfer this over to right hand side. This will give me 180 minus 59. So let me just show you what is 180 minus 59. So this will carry over. So 10 minus 9 is 1. So 7 minus 5 is simply 2 and 1. So this will give me 121 degrees, right? So this was the angle that we were looking forward for. This is 121. You can also add on, they will form 180 degree. That will prove that sum of all the angles of a a triangle is 180 degrees. So this was all about this question. That's all. So students, let's move further to the next question right here. Now question number 3, in the given figure here, you can see if AB is parallel to DE. So it is given to us that if this line is parallel to DE, that means AB is parallel to DE is given to us, right? Now angle BAC, you can see here angle BAC, that means this is given to us as 35 degrees, right? And angle CDE, so you can see here CDE, that is this one is also given to us as 53 degrees, right? Now what we have to do is simply find out angle DCE. So let me just mark that DCE is this angle. So we have to simply find out this angle DCE, right? So this was the question. Now if you can see here how we will find this angle. So this is the real question, right? So let me just tell you the method. If you just see that triangle CD is forming right here. So there's a triangle CDE. So in a triangle there are 3 angles. So angle C, angle D and angle E. We know this angle. So if we be able to find angle E, then simply adding all the angles will get me 180. So simply adding these 2 angles and subtracting it from 180 will give me this angle C, right? So this is the method by which we are going to find this angle. So let me first find angle E. So that means angle CED, what we have to find right now. For that, if you just observe that these 2 lines, a pair of lines is parallel to each other, and this AE is actually a transversal which is intersecting both the parallel lines, if you can see here. So there is a Z formation if you just see here. So these are the alternate angles. So lines are parallel given to us, that means both the angles are going to be equal, right? So this is also going to be 35 degrees. So let me write it how we will get this. So we know that AB is parallel to DE. So let me just write the solution. So we know AB is parallel to DE, right? So this implies angle BAC, that is BAC, or you can also write it as BAE. So there is no change. So angle BAE is equal to angle AED. So ADE. So you can see angle A is equal to angle E. Sorry, let me just write it clear. AED, right? So both are now alternate angles, right? So angle AED is equal to BAC, right? This is what I have written. So alternate angles, right? So lines are parallel, that means alternate angles are going to be equal. So both you can see will be equal to, let me just make some space, 35 degrees, right? So this is also going to be 35 degrees. Now we know both the 2 angles, simply add them and subtract them from 180 will give me this. So I'm taking this triangle CDE. So now in triangle CDE, we have, now let me just simply add all the 3 angles. So first angle is DCE. Let me write that. So angle DCE plus angle CDE. You can see here, plus the last, that is CED. So CED equal to 180. You can write that sum of all the angles of a triangle is 180. Now, but what is angle C? That is what we have to find. So leave it as it is. So angle DCE plus angle D. What is D? That is 53 degrees, right? Now further, E angle is 35 degrees. That's what we have find out here, right? You can see here, this is what angle E is. You can see here. So 35 degrees equal to 180. Now simply add them. So 5 plus 3 is 8 and 3 plus 5 is 8. So that will total to 88 degrees, right? Now transfer this 88 over to that side. Let me just rub the space here. So we have to find out DCE. So you can see here, transfer this over to right hand side. So this will give me angle DCE as 180. Now minus 88. This will become of negative after moving to the right hand side. So if I simply subtract 88 from 180, that will give me 10 minus 8 is 2. So now this will give me 9. 17 minus 8 is 9. So 92 degrees. So this is angle DCE that we were looking for in this question, right? So this is going to be 92 degrees, right? So that's all about this question. So students, let's move further to next question. Now question number 4 here, in the given figure right here, if lines PQ and RS, so let me just mark them. So you can see here these two lines PQ and RS, both are intersecting at a common point T. So remember here a formation of vertically opposite angle is there, right? So these two are going to be vertically opposite angle and they are going to be equal. Let me tell you. Now further, let me just read the question first. So such that angle PRT, so what is angle PRT? PRT is given to us as 40 degrees. Further angle RPT is 95. So let me just mark that RPT, this angle is 95. Also there's another angle, you can see TSQ. So TSQ is 75 degrees, right? So three angles are given to us, 40, 95 and 75 respectively, right? Now what we have to find out, angle SQT. So angle SQT. So this is the angle what we have to find out in this question. Now let me tell you the method by which we are going to do so. Now you can see here there are two triangles forming here. One is PRT and the other one is SQT, right? So both the triangles, you can see here there are two vertically opposite angles named as PTR and STQ, right? So these are vertically opposite angles. Now let me first find this angle. You can see in this triangle we know the two angles. So we can find out the third one by simply adding them and subtracting them from 180 degree. So we will get this angle, right? So both the angles are equal. That means this angle is going to be equal to this one. That means this is also, we can find out. Now if you see again in coming to this triangle, we know these two angles. So we can simply find out the third one by adding them and subtracting them from 180. So we will get this angle. This was our motto, that we have to find this angle, right? So we know the method. Simply first we will find out this angle and then equate it with the vertically opposite angle. Then adding them and subtracting we will get that one, right? Now first step is we have to find out this angle named as PTR. So first step is in this triangle PRT. So in triangle, let me just write the solution here first. So in triangle PRT, we have all the three angles going to have the sum equal to 180. So let me name them angle RPT. So angle RPT, let me just write R clear, plus angle PRT, means this one, and then angle PTR. So angle PTR totals to 180. You can write sum of all angles of a triangle is 180, same. Now angle P here is 95. So I'm doing it fast, it's quite easy now. Angle R is 40 plus angle T, that is what we have to find out first. So PTR totals to 180. Now add them, that will give me 0 plus 5, 5. 4 plus 9 is 13. Angle PTR, let me just write clear, equal to 180 degrees. Now transfer this 135 there. So this will give me angle PTR as 180 minus 135 degrees. So what is that? So let me just subtract it right here. So 180 minus 135. So 10 minus 5 is 5. 7 minus 3 is 4. So this will give me as 45 degrees, right? So angle PTR is now 45 degrees, right? So let me just write that. So you can see both angles are vertically opposite angle. That means they are equal. That means angle STQ is now going to be equal to PTR, right? So let me rub the space above here. So I'm going to rub all this question because we know what we have to find out, this angle. So let me rub this also so that there will be more space. Now you can see here angle STQ, this one is going to be equal to angle PTR. Both are going to be equal to, you can see, 45 degrees. So this is also going to be 45 degree, right? Because they are vertically opposite angles, right? Because lines are intersecting at a common point. So these are vertically opposite angles, right? Now we know this angle. So coming on to this triangle, that is SQT. So let me just write that in triangle SQT we have, let me just add all the three angles. So let me name them. So first one is TSQ, then adding STQ, and the last one which we have to find, that is SQT, right? Equals to 180. You can write the sum of all angles of a triangle is 180. Same. So angle S here you can see is 75. So let me just write that. Now angle T is 45 plus angle SQT, what we have to find, right? So simply add them. Let me first rub the space below. Let me just rub it off, right? So you can see here 75 plus 45. Now 5 plus 5 is 10. 5 plus 7 is 12. So 120 degree is the total here, equal to 180. So transferring this over to that, so SQT will be 180 minus 120, and you all know that is 60 degrees, right? So angle SQT here you can see is 60 degree, right? So this is what we have to find in this question, right? So this is how we have to perform these type of questions, right? That's all. So students, now I have left question number 5th for you to try at home, and moving on to question number 6 here. So but do try question number 5th. It's kind of the similar one to the previous questions that I've done on the board, right? Now moving on to question number 6. So this is going to be the last question, not only of this exercise but also of this chapter. So do observe it very carefully, right? Now the question number 6 here is, in the given figure, the side QR of a triangle PQR is produced to a point S. So let me just observe the side QR here of a triangle PQR, right? So you can see here in this triangle PQR, this side QR is extended to a point S, right? So this is given to us in the question. Now, if the bisector of triangle PQR, let me just tell you that angle PQR, this is the angle Q. So this is the bisector of this angle. We know that the bisector means dividing those angle into two equal parts. So dividing that angle into two equal parts. So this is the bisector named as QT. So QT is bisector of angle PQR, right? It is given to us. And PRS, so here you can see bisector of PRS, that is TR. You can see this angle PRS. So this is TR is the bisector of this angle, right? So it is dividing it into two equal parts. So these two bisectors are actually meeting at a point T. So a common point T, both the bisectors of angle PQR and PRS is meeting at point T, right? Then what we have to find out, or you can say prove. So here what we have to prove is angle QTR. Let me just mark that, angle QTR. That means this angle is equal to, you can see, half of angle QPR. So you can see what you have to do is simply prove that this angle is actually half of this angle. So you can see if this is 30, that means we have to prove that this angle is of 15 degrees, right? Or you can say this is 60, so we have to prove that this angle is of 30 degrees. So what we have to prove here is that angle QTR is half of angle QPR. Now, how we will do so? Just observe it step by step. I'm going to explain you stepwise, right? So the first step here, if you just observe this triangle PQR. So in the triangle PQR, I'm starting right from here. So in triangle PQR, right? So if you observe that, the two angles, angle P and angle Q. So you can see there's another triangle, external triangle. So there's another external angle that is named as PRS. So we know the external angle property of a triangle, and that is that the value of external angle is equal to the sum of interior opposite angles, right? So here we can say that angle P plus angle PQR is equal to angle PRS, right? So let me write that. So angle P plus angle PQR is equal to angle PRS. You can see here. So the sum of both the angles is going to be equal to the external angle. So this is going to be the first statement I have written here. Now, thing is, if we just simply half them, so multiplying both sides by half, so what we get is half angle P plus half angle. So let me multiply it with both inside. So half angle P plus half angle PQR equal to half angle PRS, right? So let me first see here. So this is as it is because there is no division. So we will going to write angle P as half angle P, same as it is. Now what is the half of angle Q? So you can see PQR. This was the angle. So half of angle PQR is TQR. You can see this is the half of complete angle. So we can write the half of PQR as TQR, right? So let me just write that angle TQR, and here as it is half angle P. Now what is the half of angle R? So let me just observe that. So half of angle R is actually, so PRS. So this was the angle, half angle R, you can say PRS. So what is the half of angle? You can see TRS. So half of angle R is this angle PRS, right? So I'm just substituting angle TRS. Give this equation as first equation, right? So let me first rub the space above so that I can move further. So students, let's move further now. You have seen here that I have formed the first equation. Now let me move to the second equation formation, right? So let me take this triangle TQR now. So in triangle TQR, let me just tell you again, I'm going to apply the similar exterior angle property on this triangle TQR. So if you just observe this triangle TQR, you will see there's an external angle again here that named as TRS. So if you can see here, so you can see this angle TRS is an exterior angle for triangle TQR, right? So if I extend this side, so this is the exterior angle, and we know the value of this angle is going to be equal to the interior opposite angles, right? So what I can write here is, so angle TRS, let me just write that, angle TRS is going to be equal to the sum of QTR plus angle TQR, this angle, because we know that this is by exterior angle property. We know that the value of exterior angle is going to be equal to the sum of interior opposite angle, means these two, right? So I have written it as QTR plus TQR is equal to TRS right here. So let me just give it a second equation, right? So if we just observe here from first and second, you can see I can substitute this angle TRS into this equation like this. So I'm going to substitute at the place of TRS as QTR plus TQR, because angle TRS is equal to this. So from first and second, so let me first change the marker here. So from first and second, we have, let me just write this equation, that is half angle P plus angle TQR is equal to TR. Now at the place of TRS, I'm going to write this because TRS is equal to this. So writing this here, so QTR plus angle TQR, right? So what you will see here now, this TQR will cancel out. So this will give me angle QTR is equal to half angle P, right? This is what we expected from here. So I have written this on the left hand side and this is on the right hand side. So no change here. So let me just first rub this in the beneath. So now what you will see here, half angle P. You can see here. So angle P can also be written as angle QPR. So let me just write as half angle QPR. That will make no change, because you can also write it as angle P or you can say angle QPR, because the angle is forming at P, right? So angle P can be written as angle QPR. That will make no change, right? So angle QTR will be as it is. So this was what we have to prove, that this angle is equal to half of this angle QPR, right? You're getting my point? So this was what we have to prove here, and we have reached that solution, right? So this was all about into this chapter. So do revise it and try to solve as much as you can so that it can be better for you to solve these type of questions. That's all from my side. Right.